Okay, so this is going to be a kind of in-depth lesson, and it's going to cover a lot of different things. So you need to pay very close attention. If you're taking notes, please make sure you write down things. I really suggest taking notes on this one so you can look back and don't have to watch the video over again. But let's just start with, what do we know about functions so far? So some of the things that you should be thinking about as you think about functions itself. Okay, some of the words are domain and range. Okay, maybe you think mapping diagram. That's something we've worked with quite a bit. Or a lot of people think of the vertical line test. When you take the MCAs, they're going to talk a lot about the vertical line test, and they give you pictures of something, and they say which one is not a function, and you use a vertical line test, whether or not it passes through the line more than once. Another thing we do is we do ordered pairs. Okay, so there's a lot of different words that are related to the word function. And so one of the things that you see a lot of is the equation. An equation can be used, so we're looking here, an equation can be used to represent a function. So, you know, we have a lot of equations that we look at in math, and really most of them, very few of them are not, but most of them are functions. It's just a way to represent a function is using an equation. Okay. Now, within an equation, we look at x comma y, this ordered pair, as being a solution to that equation. Okay, so we can look at these over here, and so these are just ordered pairs, and the question is, are any of them solutions? And so if we want to figure out if any of them are solutions, we actually have to go through the work of plugging them in. So let's start with the first one, 1 comma 5. I have to plug in 5 for y, 1 for x. And then I go through the math, and 2 times 1 is 2, plus 3 is 5. And because I got 5 equals 5, 1 comma 5 is a solution. So yes, this is a solution. Okay, let's try the next one. Now the next one says that when x is 2, y is 7. So we'll try that. So when x is 2, y is 7. So we plug in 2 for x and 7 for y. We go through the math. 2 times 2 is 4, plus 3. 4 plus 3 is 7. 7 equals 7. Hey, that's a solution also. Okay. Now the third one we have here is 1 comma 6. Now I can tell you right now it's not going to work, just because if I look at this, you'll notice that this first one has a 1 and this one has a 1. Now according to functions, and I'm telling you this is a function, according to functions, whatever you have for the x, if 1 gives you a 5, then later on 1 cannot give you a 6. That's impossible. See, 1 times 2 is always 2, and 2 plus 3 is always 5. It's never going to be 6. So that's a really big thing with functions, is that whatever, if they have the same x value, then the y value has to match up. So I can automatically say, no way, this cannot happen. This is not part of a solution, because earlier the 1 worked with the 5, so it's not going to work later with the 6. Okay, so if you're wondering if something's a solution, all you have to do is plug it in, and if it gives you something true, then yes, it is a solution. Okay, now, domain and range. You know, I wrote that up here, domain and range. Domain, remember, domain is the collection of x values, so it's all the x values that work. So far, 1 and 2 are in my domain of this. Okay, range are all the y values. So far, 5 and 7 are in my range here. Now later on, we're going to have to figure out domain and range of things. And so just remember, domain are the x values, range are the y values. And this happens a lot in math classes that we ask for those things. So those are some words that you really want to pay attention to and know. All right. Now, these next two things, the input and the output, these are things that are going to be important to have in your notes, so that if I use the word input or if I use the word independent, you're going to know what I'm talking about. So right now is a really good time to hit pause and actually write this down in your notes so that you don't get behind on what we're doing. Okay, so when we talk about the input variable, okay, so if I'm looking down here, my input variable is the one that I plug in. Now, usually it's an x. Actually, let's look up here. If I look up here, my input, I usually plug in for x, don't I? I usually plug in the 1, and I see what it gives me for the y. So normally my input is an x, okay? So whatever I plug in is my input. But we also call it our independent variable. And we call it independent because just like you want to be independent, you want to be an adult, you want to be able to do whatever you want to have the choice of whether you go here or whether you go there. That's independence. Okay, as a mom, I would love the independence from my children. Okay, I have young children, and so I would love to be able to just walk out of the house and go to the grocery store. I can't. So in a way, I'm not independent myself. Okay, but independent is the one that you plug in for. Usually it's the x. and it's surrounded by all the junk. That's the one that you're going to do the math, and it's going to tell you the other one. So if we look down here at the example, t is my independent variable because I'm going to plug in for t. I'm going to multiply it times 32. I'm going to add 79, and that's going to tell me the m. So independent and input are the same. Okay, now output is the one that you're told. After you plug in for that and you do the math, what do you find out? You find out that m equals that. Or up here, if you plug in for x and you do all the math, then you find out y equals that. So that is your output. Okay, now usually it's y, because it usually says y equals. Okay, so usually it's y. But over here you'll see that it's an m. And we also call this the dependent variable, because what you get for y depends on what you plug in for x. If I plug in a 1 here, I'm going to get 5 for that one. It depended on what I plugged in. If I plug in a 2 here, I'm going to get 7 for that one. So if I plug in 2, it'll change. So this depends on what you plug in there. So it's our dependent variable. So as we already talked about here, my independent variable is the one that I would plug in for. Here, I'm going to plug in for t. So t is my independent variable. And my dependent variable is the one that I get as an answer. That's going to be my m. So you'll be asked to answer that kind of stuff on homework or on a test. So make sure you can do that. Okay, now for our next page, we're talking about graphing these things. Now, you have all taken Algebra 1 and you've taken geometry, and so you've had to be able to graph a line. So really graphing this line, we already know slope and y-intercept. We'll talk about that in a little bit. But your other option, if you don't know how to graph something, and it doesn't matter if we're talking about x, maybe it's an x to the 5th, maybe it's x squared, maybe it's 1 over x, maybe it's sine of x. It doesn't matter. This will always work. This will always work for you. First, what you're going to do is you're going to make a table. Okay, so I pick points. Let's say I pick, I pick 0, 1, 2, 4. Okay, I pick those points, and I'm going to plug them in. And so then I plug it in for x. These are my x values. I plug it in for x, so I plug in 0, and 3 times 0 is 0, plus 1 is 1. I plug in 1. 1 times 3 is 3, plus 1 is 4. I plug in 2. 2 times 3 is 6, plus 1 is 7. I plug in 4, and I get 13. Okay, so I plug those ones in. And now what I do is I just graph the points that I plugged in. So let me make this a little bit bigger so it's easier to graph. All right, so I plugged in 0 and I got 1. You plug in 1 and you get 4. Plug in 2 and you get 7. And then I skipped 1 and I plugged in 4 and I got 13. So 7, 8, 9, 10, 11, 12, 13. It's going to be way up here. Okay. Now if you look at this one happens to be a line. We shouldn't be very surprised about that. But what you do is you graph the points and we see a pattern, and the pattern we see is that we have this line. So then what we do is we connect it. Now because it's a line, we just make a straight line. Now sometimes it's curved like a parabola, or it looks like an S or something like that. And so we just graph what it looks like. Maybe it's going to be a circle or something like that. Okay, so whenever you have to graph a function, this is a possibility. Now, more specifically, we have a linear function. Okay, now you should recognize a linear function because back in algebra we did the Barbie bungee and stuff like that, and we had to use linear function. Now, if you remember in the linear function, x and y will always be there, but m, if you remember, m is your slope. That's going to tell you your rise over run. B is your y-intercept. Okay, so if we go back to our example up here, and I do my loop-d's, remember loop-d's? And I do that, and I go plus 3, plus 3, plus 4. Over here, it's plus 1, and then this one's plus 2. If I want to figure out my slope, what I do is I take my y loop-d over my x loop-d. So I get 3 over 1. Now if I do the next one, my y loop-d over my x loop-d, I get 3 over 1 again. Now if I do the third one, I get 4 over 4. Oh my goodness, that's not 4, is it? Okay, it's not 4. 7 plus, it's going to be a 6. So for my x loop-d, or my y loop-d, I get 6 over 2, which reduces to 3 over 1. So you'll notice for all three of them, I get 3 over 1. That's my slope. But also notice 3 over 1 is just 3. And look at what number's in front of the x. It's my slope. So the number that's attached to the x is your loop-d number. That is going to be your slope. Okay, the other part of this is that your y-intercept is 0, 1. And that's because on your y-intercept, x is 0, y is 1. So we have that if we were to plug in 0 here, we would just get 1. So our y-intercept, x is 0, and that'll tell us our y-intercept, which is 1, which matches. It also matches up on the graph to look at our slope. So our slope, if we go from one point to the other, is I go up 3. I go up 3 from this point. I go up 3 over 1, up 3 over 1. Now you'll notice the next one I go up 6 over 1, but I could go up 3 over 1 and I would get to my next point anyway. So slope can be as big as you want, 6 over 2. Maybe we want to do 12 over 4. We're still going to get to another point on the line. That's the cool thing about slope, is it can be reduced, or it could be one of the bigger fractions that needs to be reduced, and you'll still get to another point on the line. Okay. All right, now for the fun part. This is the part I really like about this lesson, is function notation. And part of it is because function notation, you guys see it as being silly and we don't need it, but really it's a very, very, I can't think of the word, sophisticated. It's a very sophisticated way of showing this, and so it's really important you learn it. Okay, function notation in general is just another way to write y. So you'll see I have y equals 3x plus 1. But really, I can replace the y with f of x. So here I have f of x equals 3x plus 1. Now let me explain how this notation works. Now f of x is not f times x. That's not it at all. Whenever you see something like this, there's no numbers whatsoever. It just says f of x, or you'll see g of x or h of x. Whenever you see this, here's what it means. Okay, that x right there, whatever letter is right there, whatever variable is right there, is telling you what your independent variable is. Meaning, in layman's terms, if I have an x there, that means I'm going to have an x over here. Okay, and the f just means it's a function. So what we're saying here is this is a function of x, meaning we're going to have stuff with an x in it. That's all that that means. Okay, now that's saying that the domain is the x. Remember, the input value, remember, domain can mean all kinds of things. Independent, input, domain is the x. Okay, the range is f of x, whatever f of x is. This is going to be your range variable, or just replace that with y. If this ever confuses you, just replace it with y. Write it down as y equals, and it means the same thing. Okay, now, like I said a little bit ago, you can also have g of x or h of x. Now that's because sometimes you want different names. Maybe I have more than one function and I want to have one that says f of x and one that says g of x. And so then I can say, hey, why don't you find f of 3? And then you know that you have to plug it in this top one. Or find g of 3 and you know you have to plug it in the bottom one. Okay, so that's kind of part of the purpose of f of x, g of x. There's way more to it also when you get higher up, especially into calculus and stuff, that you need this notation. But it's important you know it before you go into those. So that's how the notation works. And so we'll just look at this as the following function linear. So if I look at this one right here, is this one linear? Well, we know linear is y equals mx plus b. So y equals mx plus b. I see mx plus b here, but then I've got this extra thing here. This is kind of a typo. It's just in the translation from one program to the other. This should say x squared. And because it has an x squared, it's definitely not linear. This is quadratic. So no, this one's not linear. Is this one linear? Yes, this one is linear because it's mx plus b. So it's just the x, just one as an exponent. Okay, let me just show you one other notation. If I had something like r of t, so this will happen a lot in physics, the rate as time is going on. What I know from this is that t is my variable. So I'm going to have all this stuff over here, and it's going to be surrounded, it's going to be surrounding t. T is going to be the variable I'm plugging in for. Okay. Now let's look at this. It says find f of 3, so I'm just going to go through and show you that. So I'm definitely going to use that one because that one has the f. So f of 3, what's happening is I'm replacing the x with 3. That means I'm going to replace all these x's with 3. So I'm going to have 3 squared plus 4 times 3 minus 1. That gives me 9 plus 12 minus 1, which would give me 20. Okay, so f of 3 equals 20. G of 3, on the other hand, if I plug in 3 here and here, why did I pick purple again? Okay, then I've got G of 3 equals negative 3 times 3 plus 4 gives me negative 9 plus 4 gives me negative 5. So G of 3 is negative 5. And really I can go back and I can say, well, x is 3 and y is 20. So I can make this notation here. And for this one, I can say x is 3 and y is negative 5. And I can have that notation. These are my ordered pairs that are part of my solutions. Okay, now let's talk about domain. because you're going to be asked to find domain. It's going to feel kind of weird. So the domain of the above functions is all reals. I can plug in any value for x, and I'm going to get all kinds of values for y. All reals. I can plug in square roots. I can plug in negatives. I can plug in positives, fractions, decimals, everything I can plug in. And then I'm going to get everything as an answer, too. I can get 1 if I wanted to. I can make it work. Okay, but sometimes when you have a context, so let's say you have a word problem, and you're asked to find the domain, not everything works. Now, we don't have this book anymore, so I'm just going to tell you what happened. These people were going on a trip, big trip, okay? And it's going to take 478 hours to get there, okay? And the function that they give us for their travel is distance equals 97.8 t. I don't know what they're doing to go 97.8 t or 97.8 miles per hour. I should maybe look it up and really know it. But anyway, here's the function. T is the number of hours it's going to take, and d is the distance. Okay? So the question is, what's the domain and what's the range? Now, think about it. Domain. Domain is all the things you plug in. So domain is going to be the t value. Okay? Now, we're not going back in time. So before they started the trip, I really don't care about that. What I care about is the very beginning of the trip. And the very beginning is 0. Time is 0. So the domain starts at 0. So that means t is greater than or equal to 0. And then it goes until the end of the trip, which they told us took 478 hours. Okay, so our domain is the t value, and it goes from 0 to 478 hours. Okay, now the range is, what do you get for d? Okay, so the range is, well, d has to be what? Okay, so let's look at it. The smallest t value is 0, so the smallest d value I'm get is going to be when I plug in 0. So I'm going to plug in 0. 0 times 97.8 is 0. So the smallest distance is 0. What about my biggest distance? Well, that's going to be when at the end of the trip. That's going to be when I get to my biggest time value. So I take that and I plug it in for t. 478 times 97.8 gives me 46,700. And that's going to be the range from my smallest to my biggest. And that's it for this lesson. I know it's a long one. I appreciate you hanging out with me.